All right, so I'm going to go over a few of the a couple of sample questions on Lab 2 just to make sure you're headed in the right direction. And keep in mind that I have posted the answers to most of these questions, so you can check your answers as you do them um, off campus. Okay, so this is Lab 1, and just hopefully you know by now that you have all the assumptions, so I never expect you to memorize any of these conversion factors, but these are all your conversion factors up here. And so use these in your problems. A couple of things to keep in mind. One, just differentiate, make sure you know the difference between heating oil and gasoline and natural gas. So natural gas is measured in CCFs. This would be for gasoline like you would use in a car or a truck, and then heating oil, it would be for heating a building. So those conversion factors, make sure you keep them straight and be careful about which type I'm asking for in the question. So these are pretty straightforward. I'm not going to go over these. One thing I do want to go over really quickly just to make sure everyone's up to speed on calculating areas. So if you look at this one, if I want to calculate how many square feet the room is and then how many square inches that is. So let's say I measure it and the room is, let's say it's a square or almost square, and I have 10 feet and I have 12 feet. All right. So my area is just 10 feet times 12 feet, right? So that's 120, and remember it's feet times feet, so it's 120 square feet. We should get used to keeping track of units here. All right, now that's actually my answer for this one. Okay, assuming my dimensions. Now I want to know how many square inches. So remember, when you're converting square feet, so I'm starting with using my process. I have 120 square feet. Remember our factor labeling, you want to put that over 1 to make it a fraction. So remember, I need to convert feet twice, because a square foot is a foot times a foot. Okay, so I need to cancel out feet twice in this one. So my conversion factor here is 1 foot is 12 inches. Okay, so that's my conversion factor. So now I need to insert my factors in this problem, and if you want to press pause and think about it, go ahead. But so I need to put here 12 inches over 1 foot, and then really important to keep in mind, you have to do that twice. So 12 inches over 1 foot. So if you do that twice, so you have feet times feet, so you have feet and feet again on the bottom. Okay, so now I check my units. I have inches times inches, so I end up with square inches. So I multiply everything across the top and divide everything on the bottom, which is 17,280 inches squared. Sorry about my marker there. Okay, so make sure you circle your answer, use your comma, any number bigger than 1,000. Okay, so the same thing goes if you're calculating, a cubic. If you're calculating a volume, you have cubic inches, cubic feet, or whatever. What you do in another problem on this assignment, right? So cubic inches. Be careful. Just make sure you're canceling out all of the inches in that one. Okay. So the rest of these I think are pretty straightforward. This one you just look up some information with the Energy Information Administration, just use Google, you'll find it. And these are I think pretty straightforward if you use some logic. I'll go over one or two of these real quickly just to make sure because, excuse me, they're all pretty much similar technique. Okay, so one thing really important to point out here, first of all, always read the instructions carefully obviously, but for this one you're converting all of these, okay, into BTUs per hour. So each one of these, we're going from whatever the unit is. So in this case here, we're going from BTUs per hour, BTUs per day to BTUs per hour. So this one, we're going from BTUs per minute to BTUs per hour. Okay, what's going on there? All right, and so it's probably pretty obvious that you already have BTUs, so you're basically just converting minutes to hours. So you want to think about what your conversion factor is. So 1 hour equals 60 minutes. That's my conversion factor. Okay. So use your same technique. So you write down the quantity as a fraction. So 10,000 BTU, and write it like that. So don't write it like this. 10,000 BTU per minute, okay? Don't write it like that. You want to actually use the fraction so you can easily keep track of what's on the top and the bottom. Okay, so now I insert my conversion factor here. So I need to cancel out minutes. So it means I need 60 minutes on the top and 1 hour on the bottom. So if I check my units first, so I cancel out minutes, and then I have BTUs per hour, which is the number I'm looking for. And so then if you multiply that out, you end up with 600,000 BTUs per hour. Okay, make sure you have your comma in there and circle your answer. And it's really that easy. So you're going to do the same thing for all of these. So here you're converting BTUs per second to BTUs per hour. This one you're actually going to have to do more than one conversion, so both kilowatt hours and days you're going to have to convert. So remember when you do something like this, in fact, I'll do this quickly. So if I have 25 kilowatt hours per day, remember I need to go to BTUs per hour, okay? Which means I need to convert kilowatt hours to BTUs and days to hours. So remember, 1 kilowatt hour is 3412 BTUs, okay? And then days to hours, of course, is 1 day is 24 hours. All right? So again, you want to write your quantity as a fraction, 20 kilowatt hours per day. Okay, and then I can insert more than one conversion factor here, which is what I'm going to do. So first, you can do it either order, it does not matter. So first I need to go from kilowatt hours to BTUs. So 1 kilowatt hour is 3,412 BTUs. Okay, and then, so I can sort of cross that out if I want to, and then I need to go from days to hours, right? So yeah, so 1 day is 24 hours, right? So then days cancel out with days. I look here, I'm left with BTUs per hour, okay? And what I end up with is 3,554 BTUs per hour. And that's it, okay? Just circle your answer, and really, it's really that easy. So you're going to use this exact same technique. You start with your fraction, and then you insert your conversion factors, you cancel out your units, and then you see what you're left with, and then you do your math, okay? So we'll do one more real quick here. So this is involving energy, power, and time. Okay, so remember our equation is that energy is power times time, okay, and power is energy over time. So in this case, I want to know my energy in watt hours given the following power and time. So this one, I just have my power is 200 watts, my time is 10 hours. I think it's good to write out what you know first, and then insert your equation, right? So I'm looking for energy, so I just multiply these two together. So my energy is just simply 200 watts times 10 hours, which is 2,000 watt hours, and that's it, okay? And so you can use those equations to figure out power, energy, and time, okay? And I think the rest of these are pretty straightforward, okay? And these are just practical applications, and then you're going to convert from watt hours to kilowatt hours and then figure out cost. So hopefully it's pretty obvious, but I've done a sample calculation here, so I'm not going to go over them again, but you can figure out by, if you have a certain amount of power used for a certain amount of time, right? So you can multiply that out and end up with your total energy use over that period of time, okay? And then I want to figure out how much it costs, so pay attention to what I'm looking for in these problems. So how much does it cost? I start with my kilowatt hours, and then I look at how much am I paying per kilowatt hour, and so you can actually go back to the assumptions at the beginning of the lab. How much am I paying per kilowatt hour? We're assuming 15 cents per kilowatt hour here, okay? And so you just apply that, basically treat it like it's a conversion factor, and you have, if you're using 12.5 kilowatt hours, think of it as another conversion factor, okay? So that should say 12.5 kilowatt hours, and then 15 cents per kilowatt hour. Cancel out your units, you're left with dollars. You multiply it out, and you get about $1.88. Okay, so you use the same exact technique that you've been using for unit conversions to actually calculate cost as well. So hopefully that's enough to help you out with Lab 2.